Okay, we're going to look at Chapter 3, Review for Test. Number 1 says, the diagram at the right represents two concurrent. So the word concurrent means acting at the same point at the same time, vectors. Which vector represents their resultant? So the resultant, this is what we did in practice A. So this is resultant, which was practice A. And the one rule for adding vectors is vectors are added head to tail, okay? So what we're going to do is, and it doesn't matter the order. So let's say I start, these are tail to tail. They are not head to tail, so I just don't connect these. So it doesn't matter which order. Let's say I did the long one first. Then from the head of this vector, I do the tail of the other. From where I start to where I end up is my resultant. So this is my resultant. Remember, this is where I start at the tail, and then this is where I end, and that's where I'm going to draw the head of my resultant. Now, what if I didn't want to do that? What if I wanted to draw this one first? So then from the head of this vector, I do the tail of the other. From where I start to where I end up, I draw my resultant. And if you look, my resultant is the same size, and it's going in the same direction. So I see there that that is going to be answer D. And that's just knowing that vectors are added head to tail. All right, number 2, it says if a woman runs, so let's just pick our frame of reference. So it's, let's put this, she runs 100 meters north. So let's say that's 100. And then 70 meters south. So from the head of this vector, I do the tail of the other. That's 70. From where she starts to where she ends up is my resultant. And you have to be careful because in this problem, it asks for the displacement, which is a vector quantity. Okay, so that's how we need to know that displacement is vector, and this is also from practice A. So displacement means the vector, so I want the resultant. And that's how we see that our answer is this. So we see 100 minus 70 is 30, and because that's pointing up, I know that it's north. And again, we need to remember our geographic directions, north, south, east, and west. Okay. So again, this is where I start and this is where I end up. All right, number 3, it says a person walks 5 kilometers north. So I'm just going to pick a starting point. So I'm just going to say, okay, that's 5 north and then 5 east. So from the head of that vector, I do the tail of the other about the same size. And it wants to know the displacement. And again, displacement, we did a lab, distance versus displacement. We know displacement is a vector quantity. So from where we start to where we end up, this is our resultant. And it just says the displacement is closest to. They don't want the angle. Well, this is a right triangle. And to find the resultant, I would use the Pythagorean theorem. So I would say 5 squared plus 5 squared. So 25 plus 25 is the square root of 50. And then I can do it on my calculator if I want, but I know that the square root of 49 is 7. So I don't even need the calculator. And I can say, well, it's a little bit more than 7. So then I look at my answers, and I see the answer here is A. All right, let's go on to number 4. So this was practice A, and A. Okay, practice B. The diagram shows a person exerting a 300 Newton force, so they're pushing on the handle, that makes an angle of 60 degrees. The component of the 300 Newton force that acts perpendicular to the ground. So this is the ground. And when I look at my components, this was practice B. This is where I'm starting. So I'm going to go like this. And then from the head of that tail, head of that vector, I do the tail of the other. So this is my horizontal component. And this is my vertical component. And I see that my vertical component, the one that's perpendicular to the ground, I see that that is this one here. Okay. So if I look at my right triangle, so let me just draw it to the side. Here I have this vector, I have this vector, and this I know is 300 newtons. And I know that this is 60 degrees. So this is what I want to find right here. Okay, so this is practice B, and we'll just call this Y. And this Y is perpendicular to the ground. This is perpendicular, and we'll just call that Y. So do I use sine, cosine, tangent? Well, here's my angle, and I want what's opposite of that, so that's going to be sine. So I would just say sine of theta is opposite over hypotenuse. So sine of 60 is equal to Y over 300. Now I'm going to move this to the other side. So I'm going to have 300 newtons times the sine of 60 degrees is equal to Y. So on my calculator, I will press 60 sine times 300 equals, and it says 259.8. So we're going to say that Y is equal to 260 newtons. So that's going to be choice B. And again, if we have the ground, this is perpendicular. Okay. All right, number 5. Which quantity includes both magnitude and direction? Well, magnitude and direction, that's the definition of a vector quantity. So again, magnitude and direction, this is the definition of a vector. So now I'm going to look at this. Mass has no direction. Time has no direction. Distance I know is scalar. So the answer is going to be D, velocity. So let's go on to number 6. So number 6 says, a rock is thrown horizontally from a cliff at 12 meters per second. So first I want to have a picture of what's going on. This is this type of a projectile where the picture looks like this. Okay. So again, if we were going to write our x and y givens, we know that ax is 0, g is negative 9.8 meters per second squared. We know that because this VI is all horizontal, VI is equal to VIX. So VIX is equal to 12 and VIY is equal to 0. It says that how long does it take the rock to fall 45 meters? So I'm measuring from here down. So y is equal to negative 45 meters. How do I know what to do first? I have 3 things on this side. So whenever I have 3 things, and remember, if I find the time here, I can find, I think we're just solving for the time in this problem. So again, when I look at my given, I know little g, I know VIY, I know y, and I want to find t. So these are my 4 variables. So now I say which equation has those 4 variables, and it's the equation y is equal to VIYT plus 1/2 GT squared. So because VIY is 0, that whole term goes to 0. So I have y is 1/2 GT squared. So I can rearrange the equation to solve for the unknown in terms of the known. So I will multiply both sides by 2. Then I'll divide by g. So I'll have 2y over g is equal to t squared. And then I'll take the square root of both sides. So t is equal to the square root of 2y over g. So it's equal to 2 times negative 45 times negative 9.8. And the negative in the numerator cancels with the negative in the denominator because I want to get a positive value for time. So 45 times 2 is 90. And then divided by 9.8 and the square root. So it comes out to be 3.03. So we'll just say 3 seconds. So the answer to number 6 is C. Okay, let's look at number 7. It says a red ball and a green ball are simultaneously thrown horizontally from the same height. The red ball has an initial speed of 40 and the green ball has an initial speed of 20. Compared to the time it takes. Well, if we go back and we look at number 6, we derive for a horizontally thrown, remember this is horizontal, so when it's a horizontal like this, we just figured out in the last question that t is equal to the square root of 2y over g. So the only thing that g is going to be constant, so the only thing that's going to make a difference for the time is how high it is above the ground. Well, these are at the same height. So the velocity is not in the equation. The only thing that makes the difference is y, the height. So the answer here is A, they're going to be the same. So again, velocity is not in the equation for a horizontal. And again, this is just horizontal. This is not one at an angle. So the only thing that makes a difference is going to be y. Okay, now let's look at number 8. So number 8 says, an object is thrown in the air and follows the path shown. Which vector best represents the acceleration of the object at that point A? Well, the only acceleration acting on this is the acceleration due to gravity. And we know that the acceleration due to gravity always acts straight down. So the answer here is going to be C. So in the air, the only acceleration is g. So remember, ax is 0, and g is going to be negative 9.8, and that's always going to point straight down. Always. So no matter what, it doesn't matter if it was here, 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 it's always going to be pointing down. Okay, let's move on to number 9. So number 9 says, the diagram below shows a baseball being hit with a bat. Angle theta represents the angle between the horizontal and the ball. Which value of theta would result in the ball traveling the longest horizontal distance? So that's going to be the greatest x. Okay. So we know that 45 degrees is the longest range, because we said that x is also called the range. Okay. So when we're looking at this, again, and the longest, that what they're asking for is this. Okay. So we know 45 degrees goes the longest. And that's for projectiles launched at an angle. So again, for projectiles launched at an angle, .45 degrees goes the farthest. Or the longest. Did they say the longest? Oh, that's the word they used. Horizontal distance. Which in physics and golf, we call that the range. Okay. Number 10. It says an archer uses a bow to fire 2 similar arrows with the same strength force. One arrow is launched at 60 degrees, and then another one is at 45. So compared to the arrow at 60, the angle at 45 was. So again, we know that 45 degrees is going to give us the longer range, or the longest range. And that's the horizontal range. So I know, so it says compared to the arrow 5, the 45 has. So first of all, just because we know that, we're going to eliminate B and D, because it's not going to be shorter. We know that the 45 is going to be longer. Now, when we had gone over this in class, we said that with a horizontal launch, again, when we looked at the complementary angles, that as we went up from the lower angles to the higher angles with the complementary angles, we had the flight time changed. So out of this and this, we see 60 degrees. The complementary angle to that would be 30. So the 30 was going to be in the air less time than the 60. So as we went up, we saw the time in the air increased. Like when we looked at the 75 and the 15. So this is how we know that the answer here is going to be C. So all we do is think about, as we increase the angle, the time in the air is also going to increase. All right, number 11. The diagram below shows the muzzle of a cannon located 50 meters above the ground. So this is my distance y. When the cannon is fired, a ball leaves with an initial horizontal speed. So this is VI, and remember, this is going to be one of the ones. This is a horizontal launch. So we know that it's going to be like this. So it says, which action would most likely increase the time? Well, this is a horizontal launch. We already derived before in questions 6 and 7 that for a horizontal launch, T is equal to the square root of 2y over g. When we know the acceleration due to gravity is constant, okay, so looking at this, the only thing that's going to increase, because it says increase the time, the only thing that would increase the time would be this, the height above the ground. So this, if this increases, then this would have to increase, okay? So the answer says pointing it towards the ground, so positioning the cannon higher above the ground, because that is Y. So the answer to number 11 is C. Okay, let's go on to number 12. A ball is thrown horizontally at a speed of 20 meters per second, so that's VI, at the top of a cliff. How long does it take the ball to fall 19 meters? So this is the same type of a problem. So we already know the equation that T is equal to the square root of 2y over g. So this is going to be the square root of 2 times negative 19.6 divided by negative 9.8 meters per second squared. Okay. Now, when you do this on the calculator, it comes out to be 19.6 times 2 equals, divided by 9.8 equals square root 2. So we'll say T is equal to 2 seconds. And I will circle that here, B. Number 13. A projectile is fired at an angle of 53 degrees to the horizontal with a speed of 8. What is the vertical component? So this is again practice B when we did horizontal and vertical components. So first I'm going to draw my picture. Here's my velocity vector. So VI is equal to 80. From where I start, I'm going to go horizontal. From the head of that vector, I do the tail of the other. This is 53. So this is my horizontal component, and this is my vertical. So it says, what is the vertical component? So I want this one that's opposite. So again, if I want, I can write sine of theta is equal to opposite over hypotenuse. Sine of 53 is equal to the vertical over 80. And then on my calculator, ran out of space, I would say that the vertical component is 80 sine of 53. So on my calculator, I'm going to press 53 sine times 80 equals, and it says 63.8. So that's going to be this answer right here, 64. Number 14, a projectile is fired with a velocity of 150 meters per second. What is the magnitude of the vertical component? So it's the same problem with different numbers. So here is my projectile. VI is equal to 150. My components, this is VIX, this is VIY, and this is 30 degrees. So since I already did the last problem, I'm just going to say VIY is equal to 150 sine of 30. And now on my calculator, I press 30 sine, it says 0.5, times 150 equals, so it says 75. So VIY is equal to 75 meters per second. And that's right here. And then our last question, which is a vector quantity? So we know vector quantities have both magnitude and direction. So because we did a whole lab on distance and displacement, we already know the answer is displacement. But again, how do we know the difference? Because a vector quantity has both magnitude and direction. And that's it.